This lesson will be a review on Chapter 7, Polynomials. In Chapter 7, we discuss the terminology monomial, binomial, trinomial, and polynomial. A monomial can be a number, a variable, or the multiplication of numbers, a number, and multiple variables. So for example, 4 x squared y to the third is a monomial. We have 4 times x squared, or times x, then times y to the third power, or 3y's multiplied. This is a monomial. A binomial, bi just meaning 2, would have 2 monomials either added or subtracted together. So, for example, a binomial is 2x minus 3yx. This has 2 monomials subtracted together, and these 2 monomials do not have like terms. In order for me to be able to combine these, my 2x would need a y on there. If I was able to combine these 2 terms, I would combine them, and then I would have a monomial. A trinomial would have 3 terms, because tri means 3. So let's look at this example. We have 4a squared plus 5a plus a plus 9. In this example, we have like terms right here. We can combine our like terms to get 4a squared plus 6a plus 9. Now that we've combined our like terms, we have 3 monomials added together. So this is a trinomial. A polynomial would be any term that has more than one monomial added or subtracted together. So a binomial is a polynomial. A trinomial is a polynomial. If I had 4 terms, that would also be a polynomial. Here's an example of a polynomial with more than 3 terms. We'll only use the word polynomial when we have more than 3, because if we have 3, we can call it a trinomial. If we have 2 terms, we can call it a binomial, or if we have 1 term, we can call it a monomial. So an example of a polynomial would be 3a plus 7ab minus 2a squared b plus 16. We have 4 terms here, so we'll call this a polynomial. We also talked about the degree of each a monomial, binomial, trinomial, and polynomial. In a monomial, the degree is how many variables you have. So in this monomial 4x squared y to the third, we have 2 x's and 3 y's, or we have 5 variables. So the degree is 5. In a binomial, we're going to look at the degree of each monomial. In this monomial, our 2x, we have a degree of 1. In this monomial, we have a degree of 2. We have 1x and 1y, so our degree is 2. The overall degree of the binomial is the degree of the highest term. So if we have a 1 here and a 2 here, our degree will be 2. The same thing will happen in a trinomial. Let's look at the degree of each term. Here we have a degree of 2 in our 4a squared. In 6a, we have a degree of 1. And in our positive 9, we have a degree of 0. So the degree of the entire trinomial is 2. And now let's find the degree of our polynomial. In our first term, we have a degree of 1. In our second term, we have a degree of 2, with 1a and 1b. In our third term, we have 2 a's and 1b, so we have a degree of 3. And in our last term, we have a degree of 0. Our degree of our entire polynomial is 3. The next thing that they discuss in Chapter 7 is the rules of exponents. There are 5 rules. In the first rule, when we're multiplying monomials, we add the exponents. So for example, if they give us 2x to the third y times, we'll do this in parentheses, 6x y to the fourth, we'll multiply everything. So we will get 2 times 6, which is 12. However, when we multiply the variables, we're adding up the exponents. So we have x to the third, and an x to the first, which will give us x to the fourth. Then we have a y to the first and a y to the fourth, which will give us y to the fifth. So when multiplying monomials, we'll actually add the exponents. We will be multiplying the coefficients, though. In our second rule, we have a power to a power. So given the example, 3x squared brought to the third power. 3 to the third power is 27. And then x to the second brought to the third power is 6. So we do have to bring our coefficient of 3 to the third power to give us 27, but we can multiply our exponents of 2 and 3 to get a new exponent of 6. And rule number 3, when dividing monomials, we can reduce or subtract our exponents. So if we're given 21x to the 6th over 3x squared, we'll reduce. So 21 over 3 reduces to 7 over 1. We can even reduce our x's. So we'd cross off 2 on the bottom and 2 on the top. So we would have 4 left on the top. In our fourth rule, when we see an exponent of 0, x to the 0 power, we get an answer of 1. However, it's only what's brought to the 0 power. So if we have 2x y to the 0, our answer would be 2x. Only the y is brought to the 0 power. In our last rule, when we have negative exponents, we'll move it to make it positive. So if we're given x to the negative second over x to the negative 6, we'll move the x to the negative second to the bottom. We'll move the x to the negative 6 to the top. And then we'll reduce our fraction. We'll cross off 2 x's on the bottom and 2 x's on the top, and we'll be left with 4 x's on the top of our fraction. Next, we'll be adding and subtracting polynomials. So first, when given any problem that has parentheses, we're going to first look to see if inside of our parentheses can be simplified. If we can combine like terms, we'll do that. So 5y to the second minus 3y and plus 8. None of these are like terms, so we can't simplify. 4y squared and minus 9, we can't combine like terms there either. Second, we'll go to the outside of our parentheses. Here we have a 1 on the outside. We'll distribute a 1, positive 1, to our first parentheses. So it's 5y squared minus 3y plus 8. Next, on our second parentheses, we have a plus sign, or a plus 1. We're going to distribute that plus 1 to our second parentheses. So plus 4y squared and minus 9. Last, we'll combine like terms. We have a positive 5y squared and a positive 4y squared. This will give us 9y to the second. Next, we have a negative 3y. And there's no other monomials here with a y to combine that with. Lastly, we have a positive 8 and a negative 1 that will combine to give us negative 1. Here's another example where we're subtracting two polynomials. The process is still the same, so first check to see if there's any like terms you can combine within your parentheses. 8x and 4x can't be 8x and 4 cannot be combined. In our second parentheses, 6x squared plus x minus 3 can't be combined. So we'll start by distributing what's on the outside of our parentheses. Here we have a plus 1, a positive 1 distributed to our first parentheses. So we'll get 8x plus 4. Here we have a negative 1. When we distribute a negative 1, all of our signs will change. So negative 1 times 6x squared will give us a negative 6x squared. Negative 1 times x will give us a negative x. Negative 1 times a negative 3 will give us a positive 3. Now we can combine our like terms. We have a negative 6x squared. Remember to always do this in descending order. So we have a negative 6x squared. Next, we have a positive 8x and a negative 1x, which will give us a positive 7x.
Last, we have a positive 4 and a positive 3, which will combine to give us a positive 7. In our next example, we'll be multiplying a polynomial by a monomial. So first, 5n times 2n to the third will give us 10n to the fourth. 5n times n squared will give us 5n to the third. 5n times 8 will give us a positive 40n. Now we'll take our second parentheses and distribute the n. n times 4 will give us a positive 4n. n times negative n will give us a negative n squared. Next, we'll combine our like terms. We have a positive 10n to the fourth, a positive 5n to the third. We have a negative 1n squared. And then we can combine our 40n and our positive 4n to give us 44n. In our last example, we'll be multiplying polynomials. When multiplying polynomials, we'll be using the distributive property. So first, we'll distribute our 8x to both the 5x and the negative 4y. 8x times 5x is 40x squared. 8x times a negative 4y gives us a negative 32xy. Next, we'll distribute our 2y to our parentheses. So 2y times 5x gives us 10yx. 2y times negative 4y gives us a negative 8y squared. Last, we'll combine our like terms. Remember that because of our commutative property, we can combine the negative 32xy and the 10yx. The commutative property says that we can switch the order of multiplication. So 10yx can be rearranged to be 10xy. So we have 40x to the second. Then we have a negative 32 and a positive 10, which will give us a negative 22xy minus 8y squared. In our last example, we'll be squaring the binomial 9x plus 3, which means that we have 9x times 3 times 9x plus 3. And when multiplying two binomials, we'll use the distributive property. So 9x times 9x, which is 81x squared, 9x times 3, which gives us 27x, then 3 times 9x, which as well gives us 27x, and 3 times 3, which gives us a positive 9. Then we'll combine our middle terms to get 81x squared plus 54x plus 9.